Chemical reactions occur when two compounds are mixed together and the atoms that make up those compounds rearrange to make a new compound. Oftentimes, when a chemical reaction occurs, we see a visible change, like a color change, a solid being produced, maybe a gas is produced, and so we see bubbles. And these types of macroscopic changes alert us to the fact that there has been a chemical change. Let's see what happens when we mix an aqueous solution of lead nitrate with an aqueous solution of potassium iodide. The two solutions are mixed, and we discover a yellow color change and a yellow solid being produced. Our macroscopic observations are that there is a color change and a solid is produced. On the microscopic level, we know that the solution of lead nitrate and the solution of potassium iodide consist of nitrate ions, polyatomic nitrate ions, iodide ions from the potassium iodide, potassium ions from the potassium iodide, and lead ions. These ions are all floating around in the aqueous solution, so there's a lot of water molecules in here as well. What happens when all of these ions are together in solution is that the lead and the iodide begin to form a lattice and a new ionic compound, lead iodide. That lead iodide is yellow in color. So on a microscopic level, the atoms and the molecules, or the ions in this case, are changing partners. The lead goes with the iodide, and the potassium and the nitrate stay in solution. When we started, the lead and the nitrate were in one solution, and the potassium and the iodide were in another solution, and so we form a new ionic compound by forming a new ionic bond between lead and iodine. It's important to be able to symbolize the chemical reactions in terms of a chemical reaction equation that will represent what is happening on a macroscopic as well as a microscopic level. To do this, we're going to write an equation where we start with the reactants, the things that we mix together. So in this case, we had lead nitrate, and we use the usual chemical formula for the compound that we mix together. But in addition to that chemical formula, we're also going to indicate that that compound was put into water, and so we had an aqueous solution of that compound. So to do that, we're going to use a AQ in parentheses to indicate that that compound was dissolved into water. So we took a solution of lead nitrate in water, and we added it to a solution of potassium iodide in water. And so we have here on the left-hand side what we call the reactants, the things that we mix together. And then something happened, so we're going to use an arrow to indicate that something has happened. And on the other side of the arrow, we're going to put the chemical symbols for the things that were left over that ended up being the products or the things that were made once we mix those two reactants together. So our microscopic understanding of this reaction indicates that we formed lead iodide, and since iodide is a -1 and lead is a 2+, I will need 2 iodides for every lead. That formed a lattice or a solid, and so I'm going to indicate that that compound was a solid. And then I also had floating around in solution potassium and nitrate ions, and so I have potassium nitrate aqueous as a product as well. So on the right-hand side we have reactants, on the left-hand side we have reactants, on the right-hand side we have the products of that reaction. Now there's one last thing that we need to do when we write a chemical reaction. The equation needs to be balanced. So what we mean when we say that the equation is balanced is that there are the same number and type of atoms or ions on either side of the equation. So we can check to see if that's the case in this equation. So we have one lead ion over here, and we have one lead ion over here. We have two nitrates because every lead goes with two nitrates. So we have two nitrate ions over here. Over here, I only have one nitrate ion. And so I'm going to need to do something to make this balanced because I need two nitrate ions on both sides of the equation. I have one potassium and one iodide over here. But over here, I have two iodides and one potassium. So to balance this equation, I'm going to need two iodides over here, and I'm going to need two nitrates over here. The thing about balancing equations is that I must not change the chemical formula for the compounds. So to balance the equation, I use coefficients in front of each of the compounds. So I can't change what is reacting and what is being produced by changing the chemical formula. I can only use coefficients to balance the equation. So in other words, I could have two potassium iodides. That would give me two iodide on this side, two because I have two of these and each one has one iodide, so now I have two iodides on this side. And I have two iodides on this side because every lead iodide gives me two iodides. But now I have two potassiums over here and only one over here. So if I put a 2 in front of the potassium nitrate, then I have two potassiums, two nitrates, because every potassium nitrate gives me one nitrate, and I have two of them, so I have two nitrates, one lead, and two iodides. So everything is balanced. Notice that this representation also helps us to understand our macroscopic observations. So we started with two solutions that were colorless and did not have any solid floating around in them. So we had aqueous solutions to start with. And when we ended up, we had a solid. And we can identify that solid as the lead iodide. And it turns out that that solid is actually yellow in color. And so we can see that this equation immediately tells us that we're going to observe a solid being formed when we mix these two compounds together.